I did some extra algebra, and you can like, I guess we're almost there. If you exponentiate this equation, right, after a little bit of algebra, you can get this to y squared minus 2xy minus x squared equals to like a constant. So like basically exponentiate both sides and then multiply by x squared, I think. Now obviously that includes an extraneous solution, because x equal to 0 is not a legit solution to this problem, is it? However, is x equal to 0 a solution to this problem in the blue? Sure is, right? So we have to be careful as we think about these things. Multiplying a differential equation, rewriting it, we can accidentally, or not, change the solution set a little bit by adjoining extraneous solutions. By, like just simplifying a differential equation doesn't necessarily keep the solution set the same. So you might be getting a slightly different differential equation. So that's another method. All right. Well, it depends on the question. If I said simplify, then that would be nice if you did that. But if you get this far correctly, I'm definitely going to give like most of the credit. So, there's a good answer, and then there's the best answer. The best answer, illustrates the mastery of algebra. So that is one of our goals in this class, is to become better at algebra than we are. I learned personally quite a bit of algebra when I took differential equations. It's been a few years. Differential equations is where I learned completing the square for a quadratic, actually. It's kind of sad, but true. Listen, there's the Bernoulli equation, there's the Riccati equation, there's the Clairaut equation. I'm going to save those for next time. The example that I think we'll do last here, unless this example goes fast, in which case we'll do those too, but that's unlikely. So this, let's see if you guys can figure out what the substitution should be for this one. All right, here's a problem. What if we were tasked with example 6? Let's see if we could figure out how to solve x over the square root of x squared plus y squared dx plus y over the square root of x squared plus y squared minus xy dy equals to 0. I'll call this star. I think we can all agree that like any of the methods we've looked at are just exceedingly unpleasant here, right? This square root of x squared plus y squared is annoying. What's its natural enemy? What did you guys learn at the end of Calculus 2 and also in Calculus 3? Coordinate systems, right? What coordinate system might be helpful here? Polar. So, may I suggest that we say x is equal to r cosine theta, and we say y is equal to r sine theta. You're like, you can do that? How do you change from Cartesian coordinates to polar coordinates in a differential equation? What do you think? What if it were as simple as we just take the differential of these equations and plug them in? That's all you do. So if I take the differential, of dx, dx is what? It is cosine theta dr minus r sine theta d theta, and dy is sine theta dr plus r cosine theta d theta. All right? So my goal is to take this differential equation in so-called Pfaffian form and to rewrite it as a differential equation in the polar coordinate system. So right there is your dx and dy. So we can put those in. And then, well, we'll figure out what goes in those square brackets in a second, but my dy is, sine theta dr plus r cosine theta d theta, right? So how do I convert what's inside the brackets? What's r equal to? Square root of x squared plus y squared, right? So what does that mean? We have cosine theta is what? X over r, right? Which is also x over the square root of x squared plus y squared, yeah? Hey, that's a what? But what is this? That fraction is a cosine theta. And y squared is r squared sine squared theta. Right? How about over here? What's that? Y over. What is y? That's y over r. What is y over r? Yeah, y over r is a sine theta. See this? This is a sine theta. And that is a minus r squared sine theta cosine theta. Putting in the polar coordinate formulas. Now I just need to do some algebra. This, of course, is all still equal to 0. Don't forget that. So let's see here. What do we got for dr? I got myself a cosine squared theta plus r squared sine squared theta cosine theta. That's from the first term. From the second term, I get a plus sine squared theta and also a minus r squared sine squared theta cosine theta. That's all my drs. My d thetas, got myself a minus r sine theta cosine theta minus r cubed sine cubed theta from the first term. And then over here, I've got a plus r sine theta cosine theta. It's a good thing we have a board of this size, otherwise I'd be in trouble. Where was I? Oh, thetas. And then minus r cubed, I should just calculate and not talk. Sine theta cosine, if I knew it was good for me, cosine squared theta. But I don't. D theta equal to 0. Let's count. I've got 2 things times 2 things. That's 4 things. I've got 2 things times 2 things. That's 4 things. 4 plus 4 is 8. I should have 8 terms. Do I have 8 terms? 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's good. Safety check. All right. Does anything cancel?
Cosine squared plus sine squared.
Oh, cosine squared plus sine squared is 1. I like that. How about this, though? Whoop, whoop. Whoop, whoop. Yeah, oh, cosine squared plus sine squared is 1. So we get what? We get, oh. Oh, so this is all. This is all just dr. That's just dr. And then over here, notice that there is a common r cubed sine theta. See, so this will simplify to like minus r cubed sine theta times sine squared theta plus cosine squared theta. Do you guys see that? If you look at the remaining two terms there, you get this, which means that that all simplifies down to minus r cubed sine theta d theta equals to 0. Can we solve that? Yeah, we can solve that, right? That's not bad. So this, separating variables, gives me dr over r cubed is equal to sine theta d theta. Integrate, integrate. Behold, minus 2 over r squared is equal to minus a cosine of a theta plus a constant. Which we can translate back into Cartesian coordinates now, since that's after all what we're interested in. That's minus 2 over x squared plus y squared is equal to minus x over the square root of x squared plus y squared plus a constant. There you go. Solved. I wonder if I got the same answer I got before. Oh, I'm an idiot. Does that 2 go upstairs? When you integrate 1 over r cubed, what do you get? It's the minus 3. Minus 3 plus 1 is minus 2. Then we have to divide by minus 2. That's integration, right? So don't let me do that. Yeah, now that of course you can multiply by minus 1 and absorb the negative into the constant. But if you look at my page 30 in my notes, this is what we derive there. We still have the Bernoulli, the Clairaut, and the Riccati equation to look at. We have like a minute. Let me show you something. Nah, you guys got stuff you got to do. We'll look at this some other day. You can go. It's. Let me not hurry. Let's relax for a change. You guys got questions?